Here's a simple problem with motional EMF. The equation is here. EMF is equal to VLB. And well, I'm going to do number 4. So let's set this up. Refer to the figure above. 15 centimeter metal rod is rolled. So I have the length. The length of the metal rod is 0.15 of a meter. Let me just indicate this on the picture so that you know what that actually means. So the length of, well, it's just the length of the rod. So I'm gonna draw it like this. Here's L. Right, so that's L. And we know the speed, it's 14 centimeters per second, which means it's 0.14 meters per second. And what else do we have? The magnitude of the magnetic field is 3 times 10 to the negative third of a Tesla. And the question is, so the unknown is, what is the voltage set up between the ends of the rod? Question mark. And so in this case, what we have is, maybe with blue, I end up with a positive, let me see, yeah, positive charge. Positive side is here, negative side is here. So this is sort of my battery, right? I could redraw this whole circuit with a battery looking like this. And so there's some kind of an EMF here or voltage, and there's a positive, there's a negative, and then the current flows like this. Here's the current I. Now this section here of the circuit has a certain resistance, and so I should add some resistance to it, to the picture. And so there's R, and in fact they do give us that resistance. They say, the problem says in number 4 that the resistance is 3 ohms. All right, so it's 3 ohms. Question is, what is the voltage? And the voltage here in this case is the EMF. And also, what is the current? I. So let's go ahead and calculate this. So the voltage or EMF would then be VLT, and the speed here is 0.14 times the length, which is 0.15, times the magnetic field, which is 3 times 10 to the negative third, equals, and so let's see what we get for this. 0.14 third, and so we get 6.3. 6.3. I don't have enough room here, so let me rewrite this. Voltage equals 6.3 times 10 to the negative fifth volts. So this would be the voltage across the rod, and then the current I would be delta V over R from Ohm's law. That would be 6.3 times 10 to the negative fifth divided by 3. And so for that we would get 2.1 times 10 to the negative fifth amps. And that's that. As a side note, I think one of the designs for a spaceship, not a spaceship, but for the International Space Stations, I think one of the designs to generate electricity there was that if you have a, so you have the magnetic field around the Earth, and let's just draw some kind of a random field here. Here's the random field. I think the idea to produce electricity, it didn't work in the end. I think it just didn't work out. But the idea was that if you have the space station that sort of sits here and moves at some speed v in this direction, you just sort of stick out a big wire like this. And as it flies through speed v, this thing gets polarized in a sense that you end up with a positive charge on the top, you have negative charge on the bottom, and so now you have a big huge battery in space. And then all that is required is to run some sort of a conductive thing from the top to the bottom, and then you have a current that flows, and you have electricity. As long as you're moving through the magnetic field of the Earth, you're good to go. So somewhere down here, you would have the Earth. I think if I remember correctly, that was the idea. But I don't think it worked out. Why exactly it didn't work out, I'm not sure. Okay, so there's a simple problem with motional EMF.